All right, well, I heard the recording message, so thank you everyone for joining us this month for the Southern California sector-specific drought outlook. It's December 11th, and yeah, as Amanda was apologizing before, we're sorry we missed prior months through the government shutdown, but we've since returned, and we think that we have a good presentation for you all today where we can share our modernizing drought early warning and our sector-specific scenarios. So I see some folks who are new to our platform here. So just to summarize what we're doing. So we have a vision for drought resilience for the nation's economic sectors. And our mission is to inform early warning decision making based on co-developed sector-specific and evidence-based drought intelligence. And we're going through this and we're learning and we're building up our capacity here. But one pillar of our activities here are to deliver sector-specific drought scenarios based on integrated and tailored monitoring and forecasting information that meets the needs of our partners, and those partners being you all. So as part of our effort here, we're focusing on 3 sectors in Southern California: agriculture, water utilities, and public health sectors. But we note that these sectors within Southern California are intimately tied into the water resources in the Southwest United States. So the perspectives that we will provide are geared toward the Southwest, obviously with a focus and an impetus on Southern California. Now, with our modernizing drought early warning, these are the past dates and also the future dates in the next several months. So we began this year's activities in August, and we resumed them again in September. October we missed, and November we did not plan on having a briefing because of all of the holidays that encompass November and December. But here we are, the second week of December, and we will again go through this exercise at the end of January, February, March, April, and May. That's at least what we're planning to do. Didn't fit on the slide here, so that's not why it's included, but we're planning to do this through next spring. So the outline of this briefing is as follows. First, we'll provide a global perspective, the global conditions that are relevant to Southern California sectors, to give us an understanding of what aspects of the weather and the climate may be relevant to Southern California as a way of trying to predict and forewarn of emerging conditions. Then we will provide a regional perspective, and that's more focused on the Southwest, conditions relevant to Southern California sectors. And then finally getting into the sector-specific drought outlook, where we will focus on water utilities, public health, and agriculture. So after each part of the sector-specific drought outlooks, I'll ask if there are any questions from our colleagues who may be listening. And those questions can be asked through the chat or through the raise hand function. Now, the lines of evidence for sector-specific scenarios, we used observed conditions, and these are the current state of the region as of this morning, unless otherwise indicated. We use predictions, expert interpretations of many types of forecasts to anticipate the future, and when possible, end of season outcomes. So we combine season to date observations and similar historical patterns to forecast the chances of outcomes. So helping to bolster up those scenarios with some constraints based on the data that we have. Now, this is a collaborative effort, at least how we've envisioned it here. So what we would like to do is to really throw it out there to our colleagues who may be listening, who are working with us. What questions do you have about drought? And what topics are you considering regarding drought and its compounding and cascading effects? And a big part of integrated information systems is capacity. What would you like to learn more about? And what do you think we should learn more about? So we can provide better information, better scenarios, and help to build our capacity in a co-developed fashion. Interpreting our sector-specific scenarios here, when we provide a scenario, we provide a confidence statement: high confidence, medium confidence, low confidence, and those are pretty self-explanatory. High confidence, close agreement; low confidence, we have little agreement among several sources of evidence. Okay, so in moving here to the global perspective, so I'm going to go back to the chat here, and I see that there are no chats and no raised hands, so I'll just get into it here with the global perspective. So when it comes to the global perspective, many have known of the importance of the El Nino Southern Oscillation, and we look at this right here because of its slow variations and its profound impact on the weather and the climate globally. It provides us an opportunity to predict future conditions in Southern California and the Southwest United States. So the El Nino Southern Oscillation is composed of El Nino, La Nina, and neutral phases, and it's related to weather anomalies that are used to predict conditions in California during many following months. A main point of emphasis here is that La Nina is forecast into early 2026, meaning that a La Nina event is ongoing. And La Nina increases the chances for below average precipitation in Southern California through winter. So that is a primary source of predictability, prediction skill, and why we focus on it as closely as we do. A good way to understand this right here is that the perturbations that are introduced into the Earth system by the El Nino Southern Oscillation and La Nina, they create waves in the atmosphere, and those waves in the atmosphere behave in somewhat predictable ways. And as a result of that, they lead to wetter and drier and colder and warmer conditions over North America. So essentially what happens during a La Nina, and if you average over a lot of different events, you get blocking high pressure over the North Pacific Ocean. What that does right there is it modifies the jet stream, and as a result, it modifies the weather over North America. So over the Southwest United States, we tend to see conditions that are drier than average, and over the Pacific Northwest, we tend to see conditions that are wetter than average. And it's really no surprise that current conditions in the West are indicating exceptional wetness in the Pacific Northwest and relative dryness in the Southwestern United States, attributed to conditions that are consistent with La Nina. This chart right here is a chart of the El Nino Southern Oscillation. There are many different ways to measure the El Nino Southern Oscillation, and some of the most popular ways are just looking at sea surface temperature departures from average in the tropical Pacific Ocean. And this right here is of what we call the relative oceanic Nino index. It helps to incorporate and include general warming patterns over the global oceans, and has really become a mainstay within our community here. Looking here in the far right part of the chart, you can see that conditions are below average for this index, meaning that a La Nina event is ongoing. And the most recent episode of La Nina has been ongoing since about the end of August of this year. Now, remember that last year was also a pretty weak to moderate La Nina event. You can see that if we back up in our time series as well. So the El Nino Southern Oscillation provides a pretty big effect, and because it behaves in a pretty slow fashion, we can use it as a way to make predictions of the future based upon it. These charts right here, what they indicate are a measure or a forecast of that relative oceanic Nino index right here. And these are from several different forecast models. And what they're indicating, at least when they were started here in December, is that conditions were below average in terms of that relative index that we look at. And as we chart forward from these forecasts, are indicating conditions that are below average. You can see that the zero line is right here, and conditions are forecast to be below average for that relative index through the early months of next year, February and March. And looking at all this information, our colleagues at the NOAA Climate Prediction Center have integrated all this information and provided their expert opinion, and are indicating that the probability of La Nina outweighs the probabilities of ENSO neutral and El Nino as we go into early next year. So this right here indicates a forecast La Nina into early 2026. So I'll go through the regional perspective, and then once I finish with the regional perspective, I will open the floor to questions and comments from our colleagues who may be listening. So in terms of the current drought, or at least the current situation in Southern California, the U.S. Drought Monitor no longer indicates drought in Southern California as of November 18th of 2025 due to heavy precipitation in mid-November of 2025. The second important point to note here is that the heavy November 2025 precipitation, despite being beneficial largely to the region, it amounts to just a small fraction of precipitation that is typically observed during the water year that spans October to the following September. And then finally, we still have significant multi-year precipitation deficits since the 1st of October of 2024, so the beginning of the last water year. And that's due principally to low precipitation in the 2024 and 2025 water year. So without further ado, here is the U.S. Drought Monitor. And the chart on the top is the Drought Monitor from December 9th of 2025. So just 2 days ago, this was released this morning. And as you can see in Southern California, the only remaining area that is mapped on this by the U.S. Drought Monitor is abnormally dry conditions, principally in the southern part of Southern California, the area that we're looking at here. This is a far cry from where we were just a month ago, and 6 months ago, and even 9 months ago here. And you can look at those conditions here with the total percent of land area that is covered by different aspects of drought indicated by the Drought Monitor. That's exceptional, extreme, severe, and moderate drought. So going back to last year, before 2025 even began, so really in the early parts of the last water year, say October 2024 to December of 2025, we noted drought building, and because of exceptionally dry conditions during that time. And because that dryness and low precipitation and high evaporative demand went into 2025, we noted the persistence of drought throughout much of the winter, spring, and summer months. But because of the precipitation that was observed, the U.S. Drought Monitor decided to remove all those drought categories in the Southern California counties that we are looking at, and they are charted here. Now, this map right here contextualizes precipitation from the 1st of October to the 6th of December, and really indicating a wet start to this water year. Precipitation, in terms of its physical units of millimeters, is shown on the left, and you can see there that heavy precipitation was observed in many Southern California counties, San Luis Obispo, Santa Barbara, even into Ventura counties. But even those counties that generally receive less precipitation further to the east, like Imperial or Riverside, they still saw notable precipitation as well. Now, if you look at the chart in the middle of the plot of the slide here, what you'll note is this is precipitation percentile to date. So basically ranking the precipitation against all other historical periods dating back to 1951. And again, this is for a period of October 1st to the 6th of December. And what you'll note here is that over Southern California, this was among the wettest, and even the wettest in some isolated areas in the Southern California counties that we look at, and other parts of California, southwestern Nevada, and western Arizona. So an exceptionally wet period over the course of about a week to two in the middle of November. Now, a cautionary tale here is shown on the right. So if you're to take this precipitation from the 1st of October 2025 to the 6th of December of 2025, and then say precipitation for this water year were to end entirely, and we weren't to see any more precipitation from now until September 30, that's what the percentile rank would look like. Note here that over areas of Southern California that we're looking at, precipitation is still below the median value, but approaching that median value. But elsewhere, across the entire region, this would rank the lowest on record. So we really want to get out there that you can have copious precipitation, you can have a big early season precipitation event, but it doesn't necessarily indicate a good water year, and that this one precipitation event will not make a good water year in and of itself. Now, despite the precipitation over Southern California that we saw in mid-November, this really hasn't translated here into snowpack and high snow water equivalent values across anywhere in the western United States. And this is as of the 9th of December of 2025. So you can see, especially in the Sierra, in California, and even in parts of the Southwest and the all-important Colorado Basin, not noting considerable values in terms of snow water equivalent. So NIDIS had just produced an assessment of snow and snowpack in the western United States, the first of the year, and I'd recommend that you go look at it because it's a very nice assessment that contextualizes the situation pretty well. Now, what we also want to do here is to be able to contextualize precipitation from the beginning of the last water year. So that means going back all the way to the 1st of October of 2024. And that's what's shown here. On the left is 1st of October 2024 to 6th of December 2025 precipitation. And you can see throughout the entire West that precipitation did fall in quite varying amounts across the region. Parts of the Southwest really received quite a bit less precipitation than elsewhere. But when you look at that in terms of a percentile to date for that entire period, the beginning of the last water year to current date, and looking at the percentile of precipitation, you see that over Southern California, and especially the coastal counties, extending from San Luis Obispo all the way to San Diego, you'll note that precipitation is in the lower 30th percentile. So quite a bit below average precipitation dating back and really indicating long-term precipitation deficits that span many different water years. Also over the Southwest, and especially in the Colorado Basin, we've seen at or or the lowest on historical record for precipitation during that period. So we did receive a good precipitation event and a good precipitation dumping in the middle of November, but that does not mean that it's alleviated significant deficits, because that map on the right really indicates that those deficits remain. Trying to flesh this out a little bit more. So this is Southern California cumulative precipitation, going all the way back to the 1st of October of 1 year, and then going through the 30th of September of 2 years hence. So basically this is encompassing 2 water years. So you can see here that precipitation tends to accumulate over the course of a winter season, remain pretty stagnant, and then accumulate once again. And the shading right here is showing the precipitation percentile rank as an accumulation over the course of 2 water years. And you can see that it generally goes up in these episodic periods as it relates to the wintertime wet season. Now, the current situation is as follows. This is the black line. What the black line is indicating right here is that over the course of 2 water years, we're still in the lower 30th percentile, but that the precipitation event that we saw in middle of November really did a lot of good in terms of alleviating those deficits. But here's a cautionary tale. You can look at 2012 and 2013, so you only have to go back about a little over a decade. And what you'll find is a situation here where, pretty similar to what we've seen so far, had 1 year of drought in 2012, and then there was a real failure of precipitation in the following year. And as a result of that, over the course of 2 water years, it ended up turning out to be the lowest on record. And as we stand currently, we stand just a little bit higher than the 2012-2013 situation. So this right here is really to come out to say that a single early season precipitation event itself only provides limited value. It helps, but it's limited value, and that we have to remain vigilant in terms of monitoring the system, the Earth system, in order to understand drought and its compounding and cascading effects. All right, we're going to get into forecasts relevant to drought, and then we'll open it up for questions from colleagues. The first part here is that no significant precipitation events are forecast over Southern California through at least December 25th of 2025. So if this were to pan out, this month would be actually quite dry in the historical record, really a failure compared to what we saw last month, where it was a very wet November. Second point here is that above average temperatures are forecast in the Southwest US for December, January, February, and March, April, May that are coming up. And likewise, below average precipitation is also forecast over those same areas of the Southwest United States. This chart right here is from CW3, so the Center of Western Weather and Water Extremes, and is exceptionally valuable in the sense that it allows us to see what the chances of an atmospheric river impinging upon the west coast of the United States are. So what the horizontal axis shows here is the days since the beginning of the forecast. So this forecast began on Wednesday, December 10th, so yesterday at 6 Universal Coordinate Time, and it goes all the way through the 25th of December. These blue values here, these blue colors indicate a low probability of seeing integrated vapor transport on the west coast of the United States. Integrated vapor transport is a measure that just shows how moisture is moving with the winds. And when we have high vapor transport, say greater than 250 kilograms per meter per second, what that indicates is a high likelihood of a precipitation event in the western, on coastal areas of the U.S. So when we don't have high probabilities of that event, of that situation occurring, it means that we're likely not to see a precipitation event. When you do see high values of that, as we are seeing right now, that means you're getting a really heavy precipitation event. And that's what's being indicated here. So the vertical portion of this chart right here shows the latitude. So you can see that through Southern California latitudes, all the way up to about 30 to 40 degrees north, 35 to 40 degrees north, we don't see a lot of integrated vapor transport in the forecast. However, we do over the Pacific Northwest. So this event that we're going through right now and what we're observing right now is just one of what is forecast to be many such events that we're supposed to see over the next 10 days. Now for December, January, February, and March, April, May forecasts, What this is indicating is an elevated probability of below average precipitation and above average temperatures. So these are forecasts that were issued by NOAA's Climate Prediction Center on the 20th of November. And what this is indicating here is an elevated likelihood of below average precipitation to the tune of around 40%, and an elevated probability of above average temperatures, also to the tune of about 40%. And the same goes for March, April, May of 2026. So based upon La Nina and waning La Nina conditions, this tends to be what we see. So the forecast that was issued by our colleagues at the Climate Prediction Center is consistent with that. All right. So that finishes up our global and regional perspectives. Are there any questions from colleagues? I would encourage everyone to use the chat or the raise hand function. All right, well, hearing none, I will.
There was one hand. Dave from BLM just raised it.
Oh, good.
Dave, can you see?
Yeah, can you guys hear me?
Yeah, go ahead.
Oh, thank you so much for the presentation. I'm just curious what soil moisture levels, like I know there's limited, BLM has a lot of land in the Mojave, and I know there's not that many scan stations. And I'm wondering what's out there for soil moisture, whether we can look into the National Water Model and look at any soil moisture levels there, or I'm just wondering what is out there for soil moisture. I used to work at the River Forecast Center, and I loved looking at the, different Sacramento SMA levels of moisture for the different basins. And now that I'm at BLM, the Mojave's so big and there's just so few observed soil moisture stations. I'm wondering if there's any way to get a look at simulated soil moisture anywhere.
Yeah, it's a great question. And there are several sources of simulated soil moisture. And I'll show those in coming slides, especially when we get into agriculture. So simulated in the sense that a land surface model is forced by observed meteorology, and we call those land data assimilation systems. And they give an estimation of what soil moisture is to be at a given location in the absence of having a sensor that may be in the ground. Obviously, a sensor in the ground is better than the alternative that is a simulated, that's a simulation, but the simulations tend to be what is more widespread used as a result of just being very difficult to get those really local sensors into the ground. So I'll get into that, but do you have a follow-up question, Dave? Did I answer your question?
Nope, that's perfect, Andy. Sorry, I forgot to lower my hand.
Oh, no problem. And I think I saw something in chat. It's Julie. I really like the addition of going back to the previous water year. Could be useful to show a third. Absolutely. Yeah, that's a great point. And I could run that calculation pretty quickly. And yeah, maybe I will, and I'll share it with you. How about that? All righty. We use 5 water years in our scoring. Yeah. No, that's good. Yeah, I can go back 5 too. Yeah, thanks for the suggestion, Julie. Okay, so here going into water utilities. So this is what our scenario is for this month. And the scenario states reservoir storage and groundwater levels are expected to be lower in June 2026 compared to October of 2025. We're highly confident in that. And the supporting evidence is as follows. The Bureau of Reclamation projects lower inflows into Lake Powell in the next 2 years based on most probable outcomes. There's low snow water equivalent across the Southwest U.S. and most of the Western United States for that matter, as of the 9th of December, so just 2 days ago. And there's an increased chance of below average precipitation through winter in 2026 and snow water equivalent on April 1, 2026, due to La Nina in late 2025 and early 2026. So we begin typically with looking at reservoir levels. So these are reservoirs across California and indicated by California Water Watch, which is a fantastic tool to be able to go and browse the hydrologic situation within the state. You can see that in Southern California, there's an indication there of near average reservoir levels, especially in Southern California. But one thing to note here is that all reservoirs are very, very different from one another, and they serve different functions and they're managed very differently. So we've decided to show this here to really illustrate that point. So this is Lake Piru, and it's in Ventura County, and you can see that here on the left where the little stake in the ground, the monitoring location, indicates the location. On the right is the time series of the storage within the reservoir in acre feet. And it goes all the way back to 2016. So the period of record here is 2016 to the near present. You can see these ups and downs. This is actually a small reservoir that's operated by United Conservation District. And you can see there's ups and downs that really follow a seasonal pattern here. Most recently, what we have seen in this lake is a release. And the release is a result of recharging groundwater, really revitalizing ecosystems. But what was interesting about last year is that conditions really didn't see much of a recovery in this lake because Southern California precipitation was low. Then you can see from the prior year, there was a big release. And that big release was really on the heels of having a pretty big year. It was a big precipitation year prior to that. So you can see these real big ups and downs in this large variability that in some ways follows a very predictable pattern of releases that tend to occur sometime in September and October. But also the most unpredictable component here happens to be the filling of these reservoirs. Like sometimes you get an extreme precipitation season like December 2022 to February 2023. And then you don't get copious precipitation in some seasons like December of 2024 to February of 2025. Now, across Southern California, groundwater levels are pretty mixed. Again, they're kind of tied in with the larger hydrology of the region and also some of these reservoirs like Lake Piru that ends up being releasing water, which then gets into the groundwater and helps to elevate that groundwater. So there's a lot of management going on. So a real local perspective there is probably the most advisable. Now, precipitation to date, what we oftentimes will do here is we will try to constrain the probabilities of outcomes at some future time. So in this case, what we're looking at here is the probability of below average precipitation for the end of the water year, that's on the left. The center panel is near average precipitation at the end of the water year in the center. And on the right, this is above average precipitation at the end of the water year. What we've done here is to find years where there was copious precipitation in Southern California. So analogs are similar precipitation to date that we saw. This being a very wet period over Southern California. This is really conditioned on those past wet periods to a similar date being October 1 to December 6. And then looking at what the end of the water year was in terms of precipitation, and then calculating the frequency of being below average, the lower third, near average, the middle third, and above average in the upper third. And what you find here in Southern California is for these years that tended to have this high precipitation in Southern California, there was an elevated probability of these years seeing near average precipitation in Southern California, and even across the general Western United States, seeing above average precipitation. So unconditioned on anything, a good start to the season will tend to leave you in a near and above average precipitation situation. The problem here is this: we are in a situation where there is a weak La Nina event ongoing. And what those weak La Nina events tend to do is they tend to lead to below average precipitation in December, January, and February, and again in March, April, May. So what we've done here is we've taken precipitation to date, that is the 1st of October to the 6th of December, and then we've added on to that analog years of waning La Nina events and weak waning La Nina events. And what we find here is that there is an elevated likelihood in Southern California of precipitation being near average and even below average. And especially over the Southwest United States, there's an elevated probability of below average precipitation if one were to consider precipitation to date and precipitation that is consistent with these analog years. So this is why we were providing such concerning information, at least early in this presentation here, because that one precipitation event that we did see in middle of November, it does not necessarily portend that the entire water year will be above average, and that we do need to remain vigilant, especially for Southern California. we need to tie into this here, especially if we're going to be looking at reservoirs and river flows, is that snow water equivalent is really off to a very poor start across the western United States, and in particular over the Southwest. And this is really playing into the scenario and the situation that below average snow water equivalent may be in the cards for the duration of this winter and springtime season, especially considering over the Southwest that we are not anticipating copious precipitation and snow for the next 2 to 3 weeks. Not the same over the Pacific Northwest. I mean, they're getting a dumping right there, but the Southwest is certainly a different story. Now, consistent with what I was showing before, that La Nina tends to lead to below average precipitation in the Southwest, La Nina tends to also lead to below average snow water equivalent in the southwestern United States. So what we've done here is to show 3 recent weak La Nina events that were sort of ending in the late winter, early spring period. This includes last year, 2025, 2018, and 2017. So we've taken snow water equivalent from NRCS and plotted this right here. And what you note is that snow water equivalent tends to be at average or below average across most of the region during these weak La Nina events. There are some outliers though, and there are some situations that don't necessarily follow the others. An example of that is 2017. So while an above average snow water equivalent season can happen during a La Nina event, it oftentimes does not. This right here is from the Bureau of Reclamation. What they do here is they provide projections of the pool elevation of Lake Powell. They also do this for Lake Mead as well. What they do is they take current conditions, and this was current as of October of 2025, and then they take historical seasons, and historical seasons in terms of flows, and then what they do is they constrain the likelihoods and the probabilities of these different pool elevations at future times based on historical conditions. So the green line right here is it shows the most probable inflow with a Lake Powell release of 7.48 million acre feet in 2026 and 2027. So this considering historical weather and climate conditions, a Lake Powell release, this is what conditions would look like. Now, they're also constraining here with the minimum inflow and the maximum inflow. Maximum incorporates the maximum values of all the water that occurred in the historical record, and the minimum being on the minimum side. The most likely outcome here is, our thoughts here is that it's probably going to be below this middle value. The reason for that, this is a La Nina event, a weak La Nina event year. And as a result of that, that tends to lead to a below average precipitation situation in the southwestern United States. So unconditioned on anything, this is where we would sit at the green, but we are conditioned on a La Nina event. And as a result of that, conditions being below average, which is why water availability in June 2026 is forecast to be lower than that of October of 2025. Okay, so this right here is the water utility scenario once again. So if there are any questions, we'd love to hear them. Okay, well, hearing none, we will move on here to our public health scenarios. So the scenarios as follows. So poor air quality due to blowing dust in Southern California is expected from March to June of 2026, and we have high confidence in that. Another part here is though a risk of poor air quality from wildfire smoke remains in spring 2026, that risk fell somewhat compared to last month due to recent precipitation. So what we saw last year in terms of really late start to the precipitation season, really high evaporative demand, which led to some late devastating fires and low air quality, that is not a likely situation just because of the prevailing weather and climate conditions that we've seen over the last month. So the supporting evidence here is that increased airborne dust is expected due to intermittent winds in spring 2026 blowing over dry land after below average precipitation from December of 2025 to May 2026, and also a significant risk of wildfire potential in Southern California through spring of 2026 is normal. One thing that we've been considering here, and this is actually where some feedback from colleagues would be great, is we do know that airborne contaminants like valley fever, for instance, are certainly a risk here, and that how would the precipitation that was observed, that we did see a copious precipitation, combined with below average precipitation and a dry land surface, lead to the risk of, say, valley fever as we go into spring? I think that would be an important value add here, and soliciting feedback from colleagues, I think, would help to provide some insights on that. So this is the air quality index, and this is wildfires on December 11th, so just this morning. And you can see that with these green dots indicating good air quality across much of Southern California and even the southwestern United States. Of course, there's some moderate air quality, especially as one goes northward, and that's a result of the prevailing weather conditions and a phenomena that we know to be what's called an inversion, which basically traps air into a given location and can reduce air quality there. But this is a far cry from what we saw last year. Over the southwestern United States, even in the middle of December, what we had noted is considerable fires just because of how dry conditions had been leading up to that point. And this is very different from the situation. This current situation is very different from the situation that we saw last year. Speaking of fires right here, this is from the National Interagency Fire Center Predictive Services. And what they do is for following months, they chart out significant wildland fire potential. And this is for January 2026 on the left, and on the right is March 2026. And noting that over Southern California and the southwestern United States, there is not an increase in the potential for an above significant wildland fire season or month as it is in this case. So that right there is a very good thing, and we've noted that the precipitation in Southern California has really led to this reduction in the risk. We showed a variation of this chart previously. So what this is showing right here is the chances of below average precipitation on the left, near average precipitation in the middle, and above average precipitation on the right. This is for December, January, February. And this is taken from analog years, so years in which we are seeing La Nina conditions and waning La Nina conditions. So we took 10 years dating back to the early 1980s, and what we did is to calculate the frequency of those precipitation outcomes. And unfortunately, what you find here is that there's a high likelihood of below average precipitation in Southern California and the southwestern United States. On the other hand, you actually see an increased likelihood of above average precipitation in some northern areas of the southwestern United States, which includes like Northern California, Northern Nevada, areas in Utah, and even into western Colorado and the upper Colorado basin. But unfortunately, over the deep southwestern United States and Southern California, La Nina really increases your risk of low average precipitation in December, January, February. Those conditions are also felt in March, April, May as well. So in years where we see a waning La Nina event, we tend to see below average precipitation. And we show this through the same perspective as we showed before, where there's an increased likelihood of below average precipitation in the Southwest during that time. And one thing that we also do need to be very aware of are wind speeds in Southern California. So this right here is for daily average wind speed averaged over the entirety of Southern California. So this isn't going to capture wind gusts at a particular location. Those would be much higher. But what this does here is to show when the main wind season is over Southern California. So what this chart shows here is that as a function of time, beginning in October and going through September, what the daily distribution of wind speeds are based on percentiles for the period of 1951 to 2023. And wind speed here is shown on the vertical axis. So what we note here is that the median value for wind speed, and I'm kind of charting this here with my cursor, reaches about 2 meters per second by the time April, May, and June roll around, reaching a maximum during that Northern Hemisphere springtime season, and then decreasing as we move through the summer, and then staying at a relatively low value through much of the fall and even into the early winter here. But one thing to note here is looking at the edges of the distribution here, that what we could observe, and we can see some really much higher values of that, especially on a daily average. So we take from this that the highest winds are possible in Southern California during the time of April, May, and June, based on this metric. And as a result of that, when we're coming off of a dry winter and springtime season in Southern California, you get those increases in the winds that can really kick up that dust, lead to some serious situations as results in airborne contaminants and effects on human health. And that's why the public health scenario is written in this way. So that finishes up our public health section of the presentation. Are there any comments or questions? Oh, Annie raised her hand. Go ahead.
Thanks, Sandy. Just wanted to comment on the valley fever incidence and how it may be impacted by precipitation. There have been some studies coming out of UC Berkeley in collaboration with California Department of Public Health, and they found that after drought, when there's a wet winter, then the following kind of end of summer fall, you tend to see increased cases of valley fever. So I think the relationship is a bit complex, but there seems to be a lag in when the increased incidence occurs.
Oh, very interesting. Yeah, that could I ask you a favor? Could you share that with me and with Amanda as well?
Yeah, I can put that in the chat.
Excellent. Yeah, that's fantastic. Sonia.
Hi, I'm new here. Annie's my supervisor. I'm a new research scientist with CDPH. I'm going to be taking over Annie's old role with Drought and Health. I also wanted to make aware, I don't know how many people are following the recent mushroom updates and mushroom picking and the morbidity associated with that, but we haven't done any studies into it yet, but anecdotally, the recent rains have had all these mushrooms flourish, and because it was drought, and now because of the different soaking, there have been people picking mushrooms and ending up with morbidity. And so that's just something we also wanted to highlight.
Oh, that's an excellent perspective. Yeah, thanks for sharing it. And yeah, welcome.
Thank you. Yeah, I'm excited to be here.
Is it your birthday? Because I see a birthday in the background.
No, it's my colleague's birthday.
Happy birthday to them. Oh, that's excellent. Yeah, thank you, Annie, for putting in those two links into the chat. They're much appreciated. Oh, yeah, that's excellent. Yeah, thank you for helping to build our capacity and to really help to co-develop with this entire process. That's sort of what we're after, and we're glad to have you all as partners. So getting here into agriculture. So the scenario is as follows. So La Nina is expected to lead to high evaporative demand and below average precipitation through spring, which may drive crop stress and reduce agricultural productivity in spring of 2026. We have high confidence in that. However, November's heavy precipitation added moisture to soils that may offset some of this crop stress. And the supporting evidence is there was heavy precipitation in mid-November of 2025, and also below average precipitation and above average evaporative demand are forecast in Southern California between December 2025 and May 2026 related to La Nina. So this chart right here indicates the growth rate of annual rangeland forage production. And we note that in October, this is the time of year when growth begins, really reaches a maximum in March, April, and May, and really winds down quickly in June as the wet season had ended a few months prior, and it's also getting very warm. So we are all at the time of year where rangeland production is important, and looking ahead to the all-important months of March, April, and May. So getting into the question that we received previously, this right here is soil moisture anomalies. This is in a percent, and this is from one metric, which is called Climate Prediction Center Soil Leaky Bucket Model. There are many different simulated soil moisture perspectives, this being one of them, and some are really complex and some are relatively simple. But we note here that on the 15th of September, which is over here on the left, that over the southwestern United States, there were some very deep deficits in soil moisture. This includes Southern California, Arizona, Utah, Nevada, and even Western Colorado as well, especially in the Southwest and monsoon areas. The monsoon didn't really perform very well over Arizona, in addition to the very dry conditions in the prior winter wet season that led to that situation. But as we move ahead here to November 20th, so this is nominally the time when precipitation had already fallen, that heavy precipitation in November, what we noted here is really copious soil moisture over Southern California, and even almost the entirety of California as well. And some of the soil moisture increases had really navigated here into Arizona. Now, if you look on the right, this is the most recent version of this. So this is December 5th. What we note here is that soil moisture is still quite a bit above average in Southern California, but I'm going to provide a cautionary tale here. So to the north of that, in Northern California, what we note here is that we had quite a bit above average conditions just 2 weeks prior to December 5th, but dry conditions in a couple week period in California can lead to a situation where your soil moisture gets bled off and it gets evaporated into the atmosphere because of the atmosphere's evaporative demand. And this can happen over Southern California as well. Just a few weeks of dry conditions would lead to a situation from which we have very wet conditions in the soils to dry conditions. So this is something that we're monitoring very, very closely. I wanted to touch on this. I went into this in some detail before, but a wet start to the current water year doesn't necessarily mean that we are going to have a good water year. And while that precipitation in mid-November was beneficial and much appreciated, it does not amount to a lot of precipitation that we tend to see during a water year. And as a result of that, we need to remain vigilant that despite seeing above average precipitation for a time, it doesn't mean that we are out of the woods. So I showed this previously. This is December, January, February frequency of above, near, and below average precipitation related to past La Nina events. And what we note here is that there's an increase in the chance of below average precipitation in the Southwest United States, particularly in Southern California. The same applies here to March, April, May as well. Now, one part of drought that we haven't touched on a lot in this presentation right here is the demand side of drought. So you can think of drought as a deficit in moisture because you don't have as much supply as you have demand. So basically your demand is much higher than your supply. You start to get fewer water resources, whether it be soil moisture, whether it be runoff, stream flow, reservoir levels. Evaporative demand can be measured in several different ways, and this is a metric that we use called EDDI, the Evaporative Demand Drought Index. What it does is it measures the demand of water from the land surface by the atmosphere and includes components like temperature, the atmospheric humidity, solar radiation, and wind. What this is showing right here, especially over Southern California, is that we haven't had above average evaporative demand for the 3 months ending on the 5th of December. This is a far cry from what we saw last year. But nonetheless, we haven't seen the demand of water by the atmosphere from the land surface being exceptional. And that's a good thing for obvious reasons. Same can't be said for parts of the Southwest United States where above average evaporative demand was indicated. Unfortunately, what happens during La Nina events is we tend to see above average evaporative demand. This was certainly the case for the 3-month period ending on the 1st of April. So now looking ahead to agriculture and agricultural yields through winter and into spring. Evaporative demand was exceptionally high for the 3 months ending on April 1, 2025. It was also very high for the 3 months ending on April 1 of 2018, those two being La Nina events. An outlier here is actually 2017, the 3 months ending on the 1st of April of 2017, where we didn't see exceptional evaporative demand. And in fact, we saw below average evaporative demand in much of the Southwest. So evaporative demand tends to be pretty high during waning La Nina events, as we're in right now, but it doesn't have to be. It's not 100% a lock. So there is perhaps some hope, for lack of a better term, that evaporative demand wouldn't be exceptionally high and drive us into deeper drought, but there's certainly an elevated chance of that, given what past occurrences we have seen. Okay, so this right here is the agriculture scenario once again. Are there any comments or questions?
I have a question.
Annie, I see your
Um,
hand up. Yes, go ahead.
Thanks. So I know that Eddie is a kind of more experimental indicator, and I was wondering if you could talk about the like how NOAA envisions Eddie being used versus U.S. Drought Monitor or SPEI.
That may be a discussion for what we discuss in a little bit. Could we hold off on discussing that for a few moments?
Yeah.
Great. Thanks, Annie.
With that, Andy, I can go ahead and end the recording if you'd like.
Yeah, that would be great.